Ever wonder why your coffee gets cold? It's not magic, it's thermodynamics. Don't worry, we're not going to get bogged down with equations. We're going to keep it simple and fun. Think of it like this. The universe has rules, and thermodynamics is like the rule book for how energy works. Let's dive in. Imagine your hot cup of coffee. The coffee has heat energy. When it cools down, the heat energy doesn't just vanish, it goes somewhere. The first law of thermodynamics says energy can't be created or destroyed, just transformed. So, the heat energy from your coffee escapes into the air, warming up the room a tiny bit. Pretty neat, huh? Now let's talk about a wind-up toy. This simple device can teach us a lot about the fundamental principles of physics and the nature of our universe. You wind it up, giving it potential energy. This energy is stored in the toy's spring, waiting to be released. As it moves, that energy transforms into kinetic energy, propelling the toy forward. It's fascinating to see how energy changes form. But notice how the toy eventually stops? This isn't just because it runs out of energy. The second law of thermodynamics tells us that things naturally move towards disorder, or entropy. Over time, systems become more chaotic. The toy's energy dissipates as heat due to friction, increasing the overall disorder. This heat is a form of energy loss that contributes to the toy's eventual stop. Just like that toy, everything in the universe tends towards a less organized state. From our cluttered desks to the vast cosmos, entropy is always at work, pushing systems towards chaos and disorder. Section 4. The third law. Absolute zero is like really, really cold. Ever heard of absolute zero? It's not just any cold, it's the ultimate cold. Imagine the coldest winter day you've ever experienced, and then multiply that by 1,000. It's the coldest possible temperature, where everything freezes solid, even atoms. At absolute zero, which is 0 Kelvin or 273.15 degrees Celsius, molecular motion comes to a near standstill. The third law of thermodynamics states that as we approach absolute zero, the entropy of a system also approaches a minimum value. Entropy is a measure of disorder, and at absolute zero, a perfect crystal would have zero entropy. Think of a solar panel. It's a great example to understand energy conversion and efficiency. It converts sunlight into electricity, but it can't convert all the sunlight. Some of the energy is always lost as heat. There's always some energy loss, preventing it from reaching 100% efficiency. This is similar to how we can never actually reach absolute zero. Absolute zero is like that. We can get close, but never quite reach it. Scientists have come incredibly close, reaching temperatures just a fraction of a degree above absolute zero. But due to the laws of physics, absolute zero remains an unattainable goal. It's a fascinating concept that pushes the boundaries of our understanding of thermodynamics and the nature of cold. Section 5. 3 laws, 1 big idea. Today we dive into the fascinating world of thermodynamics, a cornerstone of physics that governs how energy moves and changes in our universe. So there you have it. The 3 laws of thermodynamics, explained simply. These laws are fundamental principles that help us understand everything from the smallest particles to the largest galaxies. The first law tells us energy is constant. This means energy cannot be created or destroyed, only transformed from one form to another. Think about how solar panels convert sunlight into electricity, or how a power plant generates energy from coal or natural gas. The second law says things tend to get messy. This is known as entropy, a measure of disorder. Over time, systems naturally progress towards a state of greater disorder. Imagine a tidy room that becomes cluttered over time without regular cleaning. And the third law reminds us that absolute zero is super-duper cold. At this temperature, molecular motion comes to a near halt. Scientists use this principle in cryogenics to study materials at extremely low temperatures. Think about these laws next time you see ice melting, a ball bouncing, or even just your breath in the cold air. It's all thermodynamics. These everyday phenomena are governed by the same principles that explain the behavior of stars and galaxies, or even just your breath in the cold air. It's all thermodynamics. The next time you see these simple events, remember the profound laws that make them possible. And hey, why not share this with your friends? Understanding these laws can change the way we see the world and appreciate the science behind everyday occurrences. Let's spread the science love. By sharing knowledge, we can inspire curiosity and a deeper appreciation for the wonders of our universe. So go ahead, share this video, and let's make science a part of everyone's life.